G'day folks, thanks for coming out this evening. My name's Nick Muldoon. I'm one of the residents here at iAccelerate. We're hosting Silicon Valley Tech Talks on about every second month. We're always looking for talks. If you haven't joined already, you should check out silicon.signup.team and join the Slack chat. There's rooms for 3D printing and the workshop downstairs and probably AWS after this. But anyway, Marty Roberts is going to share with us some stuff about Amazon Web Services and Internet of Things this evening. And then I think we're going to throw it out to the floor to decide what we're going to get Sam to talk about. And Sam's got a couple of talks that he can do as well. So thanks so much. Over to you, Marty.
Thank you. Okay, hi. My name is Marty Roberts, martin.roberts@italk.com.au. I should have changed it to Marty ages ago, but now I've got this thing where everybody calls me Marty, but got martin.roberts. Anyway, I work for a company called iTalk. They're a consulting company, mainly dealing with AWS consulting, so Amazon Web Services, if you haven't heard of them. Sorry to ask you to do this, but can you just put up your hand if you've heard of Amazon Web Services, please? Excellent, thank you. It means I don't have to do the whole spiel about what's AWS services. Okay, so yeah, I work for a consulting company that basically helps enterprises, mainly enterprises, with their journey to the cloud with AWS services. That's migration, all sorts of design, solutions. I'm a solutions architect, so I'll work with businesses on designing systems and automating deployment of some systems into the cloud, working with dev teams. I'll sometimes work as a tech lead with dev teams. Yeah, so that's basically it. I'll go to the next slide. So just a little bit about myself, a bit of history. Born in Sydney, and I went to the UK for 3 years and worked over there for some big companies, and came back to Sydney, had some kids, and my wife and I decided that we wanted to get out of the rat race, and beginning of the year we moved down to Thirroul. So that's the beach there, Thirroul Beach. Very nice. And yeah, so I've worked for some big companies. I've only really worked for enterprises for the last probably 15 years or so. Getting a very good understanding of how enterprises operate, what their concerns are, how hard it is to get things done. Over the last 5 years, I've been working at. I was working at Suncorp. I left at the end of last year, or middle of last year. Something that I find interesting about enterprises is, as a consultant, is actually is trying to help them to become more agile through the use of technology. And being able to adapt quickly to change, because the worst thing that enterprises can do is stay still. There's too many fintechs and startups coming through, and that are going to wipe them out ultimately if they don't do something about it. So at Suncorp, I was working with their. They had a strategic arm of their IT department that was either looking at new technology or working with actually acquiring startups to try and almost undermine their own business model. So I have a lot of fun with working with enterprises and almost going in there as a bit of a disruptor to their existing to the existing way that they do business and developing new systems. So yeah, go to the next slide. This sometimes it's difficult coming into these things because you don't know what the level of technical knowledge is from the crowd. However, I think this is important to go through because I really feel like we're at a point with technology at the moment where I think you would all agree that the technology is accelerating. It's not just a slow increase in development of technology and adoption of technology, increase in services over time. It's actually getting faster and faster. And I know that through, I guess, just the rate at which I have to learn. I've been in the industry for probably about 20 years, and I find now I'm having to learn more rapidly than any other time in my career, right? And yes, exactly. But I find it's fascinating. I think that being someone who's been in the industry for a while, I can see that. I guess if you're young and you've just come into the industry, you probably just think, well, this is normal. This is the way it is. But it's really is speeding up. It's just getting faster and faster, and the change is more rapid. AWS released over 1,000 new features and services last year. That's the rate at which change is occurring in technology. And you know, it is hard to keep up, even as a consultant. I find it really hard to keep up with it. Yeah, so I thought it's just good to take a bit of a look back, right? When I was living over in London, I worked for Barclays Capital. They had a data centre that was as big as a football field and had about 2,000 physical servers in it. Each one of those services ran a task, right? And they all looked like that, and they're in racks, and they had this thing on there. You could go to their website and click on this link, and it said you know, information about their technology. They're really proud that they could heat up an Olympic swimming pool to boiling point within a 24-hour period with the heat that came off their data centre. So you know, this was early 2000s, so it's not that long ago, kind of. I came back to Australia in about 2003, and I was doing some work at Coca-Cola, and they were just starting to look at VMware. They were just starting to play around with it. And then I moved on to Suncorp, and they, within a few years, they had kicked off a huge data center migration from physical to virtual. Now, what amazes me is I'm still going out to customers now that have got loads of physical servers sitting in racks running workloads. And so you've got this with enterprises and even small businesses. The company that I was, who was it now? I won't say who it was actually, but yeah, they had about 60 physical servers still sitting in racks, just running single workloads, and the virtual infrastructure that they had was it was almost like a, oh yeah, this is something we're playing around with. And I kind of thought, it's just crazy that at this time you've got people that still have servers in racks running, you know, specific workloads. So obviously, if you don't know what virtualization is, it's basically running loads of OSs in one of those things. So instead of having a single workload running in that, you'll have like 50. And the reason why that happened was obviously with pressure of trying to get more density of workloads into physical gear. You'd have an application running in there, running a website, and the CPU on it might be running at, you know, 10% most of the time. And so obviously engineers thought, hey, we can get more out of this piece of physical equipment. So then came along the hypervisor, which they would put on top of that thing. You could carve up this server so that you would have lots of OSs running on it. And so each one might be running at, say, 50% or something like that, just for argument's sake. It would get more out of the physical hardware. The problem is you had VMware, who was pretty awesome, and Hyper-V, they're great as well. But the problem is you can't move that VM there over to that hypervisor. So if you're a Microsoft shop and you're running you know, VMs in Microsoft and you want to move them over to VMware, it's really hard. It's a pain in the butt because you've got all these agents on there and things that are very specific to those hypervisors. You can't move them around. It's a pain, real pain. So about 10 years this reigned, right? 10 years. And now it's like being completely disrupted by Docker. Right, so Docker's come along. What Docker's done is it's a container, and you can move it anywhere. You can move it onto Microsoft stuff, you can move it onto Google, you can move it onto Amazon, you can move it on premise. In fact, you can even have a laptop, which some of you may know. Just hands for Docker. Anybody knows about Docker? Oh, thanks for that. So, sorry if I'm making this sound really, I don't know, trivial. But yeah, but basically what you can do is a developer can create something called a Docker container, and it's a self-contained application with all of the things that it needs to run, and it can run on the laptop, and then you can take that artifact. So if you're a developer, you take that Docker container, you can then put it into development, you can put it into your test environment, you can put it into production. It stays exactly the same, and you know the developer knows that when they move that from this location on their laptop to when it gets into the production and it's serving customers, that all the dependencies and everything about it are exactly the same. Right? So the old model was around moving code, and the problem with that is you went from running the code on your laptop and it worked, and then you put it into production and then it wouldn't work because there'd be some dependency or something that was a bit different about the environment. So Docker is really good for developers because if it works on the laptop, it'll work in production. And I know I'm really simplifying things there for the Docker guys, but developers love it, right? Because you can create the container and then move it around. And you can move it from your laptop out to the cloud or a different cloud provider. Now, Docker. Can somebody who knows about Docker tell me how long they've been using it for? Who thinks that they've been using it for the longest amount of time? What do you reckon? 5 years? More than that? More than 5 years?
No, about 4 years.
4 years? Okay, so Docker 4 years, say?
Yeah.
So I would say, like, I'm not an expert on Docker, right? But Docker has probably only really been used in anger in enterprises for how long? 4 years, you reckon?
Oh, in anger, in enterprise?
In anger, yes.
12 or 18 months.
Exactly, exactly. And I find this fascinating, right? I was at Suncorp and they were talking about what Docker platform were you going to use? We're going to use Red Hat's version, what's that called? Red something or other? Redshift? No?
It's not Redshift.
What's it called?
That's the AWS.
Anyway, Red Hat have one. It's very popular. OpenShift. OpenShift. Cloud Foundry is another one. Okay, you've got AWS, you've got ECS. I'm sure there's loads of others. There's all these platforms out there that you can put your containers on, right? And they've all got different features and all that kind of stuff. And developers all have arguments about it. Go, oh no, this one's the best, that one's the best. I want to work with that one because I like it and all the rest of it. So Suncorp, when I was there, they were talking about moving all of their Java apps, hundreds and hundreds and hundreds of Java apps, right, onto Docker. And I went to management. I said, you guys are crazy. It's going to take you, how long is it going to take you to move hundreds of Java apps onto a completely new platform, onto Docker? It's going to take them years, right? And the reason why I said they were crazy is because the development of serverless technology, which is appearing at the moment with Google, with Azure, with IBM, with AWS, there's a new technology called serverless that's only really been around for the last, people, can you put your hand up if you know about serverless technology, please? Yeah. So what do you reckon, what sort of enterprises would be, how long do you think enterprises have been using serverless technology? What do you reckon?
0 months.
0? Right?
Are they using it?
No. Not that I know of. The thing is though, this is coming, right? This is coming. And the thing that I warned, when I was at Suncorp before I left, the thing that I warned them about is they're about to embark on a 4 or 5 year migration program and move all their apps onto Docker. And they're faced with this opportunity that's coming around potentially re-architecting their apps instead of just taking the Java code and refactoring it so it works in a Docker container and then they can deploy it into wherever they want, right? So to them, this thing's coming, right? It's like the wave, down at Royal Beach. It's there. It's coming. You can see it's coming, and you're going to spend 4 or 5 years moving these Java apps that you've tweaked for the last I don't know how many years into a container so that you can then move them out to the cloud. And the reason why I was so passionate about it when I was there was because, well, technology is going to completely change in the next 5 years. You don't want to embark on a 4 or 5 year program to move Java apps out to Docker containers on the cloud. What serverless does is basically you take a piece of code and you run it. It only executes when it needs to run. Okay, so if you've got a website that has an API that returns some data. In fact, I'll show you an example because I've got a prototype of this that I've been working on. So I've done a prototype on a GPS tracker that uses the LoRa radio. Does anybody know there's a LoRaWAN gateway here? You put your hand up if you know there's a LoRaWAN gateway in this premises.
Explain what that is.
No, nobody knows. This is amazing. I'm not saying that you should know. I just think it's incredible how there's one here and nobody knows about it. It should be advertised more. So what LoRaWAN is, right? This is a massive segue. I've got to come back to this. But basically what it is LoRa is a proprietary licensed radio technology by a company called Semtech. There are other competing technologies, but basically what it is, it's an IoT technology. It's low-powered, long-range, small data rate radio. Okay, so it's great for things like farming, where or agriculture, where you want to have sensors where you can basically have, something on a cow that's 10 kilometres away, and you know where it is here. right? So it's that sort of technology. No 3G, it's not wireless, it's a radio technology that's been developed to deal with this kind of low data rate, which most IoT is low data rate, a lot of it. Low power, you want a battery that's going to last for like 10 years, right? And you want it on a tree that's in a forest somewhere and pinging back and saying, hey, I'm this temperature, right? That's what the technology is used for. So LoRa, this technology, this radio technology, is filling this gap that's currently there around 3G, and a lot of the telcos are developing low power 3G, right? So, but they're all just trying to fight against something which it's a technology. The 3G technology isn't designed for low power, right? Or long range, not 10Ks anyway. So that's basically what LoRaWAN is. There's a LoRaWAN gateway here. Yep.
How do you spell LoRa?
LoRa. Now LoRa is it's like the Mac level network protocol. It allows networking communication. LoRaWAN is what turns that protocol into an internet protocol. So basically you can have a device that can actually connect to the internet and talk to internet services. There's a LoRaWAN gateway just here. I live at Thirroul and I tried to use it, but I was too far away. So I actually set a LoRa gateway up in my house, right? And it cost me about $50. And I'll show you the results of that in a sec. Now, where was I? Does that answer your question?
Sorry, can I just comment? Would you say it would still be relevant with 5G coming?
It's all about the low power. Can you take a 5G transmitter, stick it on a cow, and with a battery in the device, and have it last for 5 years? Right? It's just not going to work. So the whole purpose of this technology is to last for a really, really long time, low power, and also long range as well, right? So yeah, possibly. I'm not an expert.
Because there would be like significant sort of infrastructure investment, right, to like get LoRaWAN across all of the country.
Absolutely. But you know what? You look up LoRaWAN and where it's being adopted. There's a company in the US that's rolling out across 100 US cities. It's being rolled out across South Korea. It's being rolled out in New Zealand. New Zealand. And it's being rolled out in Taiwan. Okay, this is a technology that's starting to, I've been monitoring this over the last couple of years, and you can see it's just starting to grow, right? So it's really, it's another one of those waves you can see coming. So yeah, if you're interested in it, just have a look. It's still early days. Yeah, there needs to be infrastructure. I'm consulting with a company at the moment that's that has a pet tracking GPS system, and they're using 3G. And they looked at LoRaWAN and they just said it's not viable because there's not enough infrastructure. So they went with 3G and 4G. So there you go. Any other questions about that? No? So serverless. What I love about serverless is that you write some code, and when I was at Suncorp, I just thought this is a great opportunity for them because they just got hundreds of microservices. Just ping something to get a postcode, or you ping something to get, I don't know, some just piece of data, or something really, really small piece of code just to go and grab something from a database or something like that, microservice, right? A serverless is perfect for that sort of thing because you're only charged for every 100 milliseconds that your code runs. And if your code is not running, you don't get charged anything. And with AWS services specifically, your first million requests are free, right? So it's pretty cheap for people that just want to try something. And you can write in Node, you can write in Java, Python, Go, and you basically just throw the code at that thing and it'll run when you want it to run, right? Anybody got any questions about that? How do you run it? How does the code run? What kicks it off? Does anybody know how you kick the code off? Yes, at the back.
Yeah, so I use AWS Lambda services to process audio.
How do you kick it off? How does it start?
It's an API endpoint, and then it goes through the API gateway.
Yeah, So there's some code you want it to run. How do I get it to run? I stick an API on the front. So an API basically sits on the internet and it waits for you to type in a URL and press enter, and it'll hit this API, which is sitting on the internet, and it'll run that with some parameters, right? Basically. Okay, it's an internet endpoint that then kicks that off and then returns some data back. So you can stick that in front. Okay, but API Lambda, which is an AWS serverless service, you can connect that up to all sorts of stuff. So for instance, with transcoding video, so you want to put a video up onto, you want video to be carved up into different formats so that you can play it to different devices or something like that. You could put a video into AWS, right, into something called an S3 bucket. You have a notification on the bucket that says, oh, this has arrived, run that. It'll then change it to 800 by 600 format or something or whatever and save it back into the bucket so that some mobile device can download it and run it or something. So you can have, that code can be run by all different mechanisms, whether it's an API that your application hits to go and pull something into a web page, which I'll show you in a minute, or it could be a notification of something happening, an event, any event in your actual enterprise or environment. You can kick that off, run it, stop, 100 milliseconds, charge you a microcent, right? And that's it. So serverless is pretty exciting because one of the problems with this container technology here that I see is that you still need to have a cluster of hosts that run your containers. Okay, like with VMware, where you have lots of virtual servers, you still have to have all this server infrastructure that all the virtual machines sit on top of. With Docker as well, with AWS, you create something called a Docker cluster, and all the Docker containers run in that cluster. You've still got this kind of capacity management issue. With serverless, you can run millions of these things, and AWS, I haven't actually worked with Azure or with OpenWhisk with IBM or with Google on their cloud functions, but with AWS, you don't have to say how big the infrastructure is underneath to run your code, right? You just basically, you could hit 1 million times and it will just launch 1 million of these things. And it's because AWS is so vast in scale, they can do that with all the available capacity that they've got. It's kind of a weird slide now considering what I've just been talking about. So with cloud, I'll just quickly go through some of this stuff and then I'll get onto my prototype. So I sort of talked about the evolution of technology, like the physical, virtual, Docker, the containerization, and then serverless, which is basically running code on demand, only getting charged for the time that it runs. So the key thing that you need to think about is density. Right, so what AWS, Azure, IBM and Google are doing is they're just squeezing as much as they possibly can out of this massive investment that they've made in all of this infrastructure that they've deployed. And that's basically what the driver is, to squeeze as much as they can out of it. So the next evolution, obviously, serverless, I guess, the reason why I've decoupled it from cloud is because AWS have actually got this serverless capability running in devices that are not in the cloud. So AWS have created this device called, what is it called again? Green something. Does anybody know? It's a device that, no, it's not Snowball, it's green.
Snowball Edge or something?
Snowball Edge maybe. Yeah, so it's basically a device. It looks like a briefcase, kind of travel bag. It's got like 60 terabytes of storage in it, and you can send it down onto a mine, or you can put it onto a ship that's going out to the ocean or whatever, and it actually runs Lambda on it, right? So it's not in the cloud. You throw code at it. You throw code at this device. So that when data is ingested, the code, so an event happens, right? You send data at it, data is, there's new data there, and the Lambda function will fire up, process the data, and then it sort of transforms it, massages it, and then puts it into storage. So this whole concept of this Lambda function isn't just cloud. In fact, I was talking to the AWS guys at the summit recently. I said, I would love to have this in my data center, all right? Not just in the cloud, I want this everywhere. I want to be able to just run code without, I want to run that code instead of deploying a server, deploying a virtual machine, to deploying a container. I just want to run that code and anywhere. So not just the cloud. That's the reason why I sort of differentiated between that and cloud. So what about cloud? I just thought I'd just quickly go through some of the things I think about with cloud. You probably all heard about cloud. I'll just really quickly go through this though, because I think a lot of these points are really important. So CloudFormation is something AWS have. 2 examples I'll just give you of this. CloudFormation is about deploying your whole infrastructure and application in basically in a script. So I work with Price Waterhouse, and I also worked with just a recent customer that I've been working with this week. They wanted, basically these 2 customers that I've worked with, they said, we want to be able to white label our product, and we want to be able to, when a new customer comes to us and they want to use it and they want to put their brand on it, we want to be able to just go, bang, there you go, put your brand on it. And so I was involved with both those customers with products that they had with using CloudFormation to deploy everything. So their application and the infrastructure, security, access, everything. So with Price Waterhouse was basically a new product that they had, and they wanted to deploy it into the UK. And so the whole environment and everything about it was scripted, and you could basically just run this thing and it would just deploy it in about 15 minutes in another region, in another country. Okay, so that's something that I find just absolutely amazing with the cloud. A lot of people I've seen in enterprises are still using cloud as their own data center. They'll go into the console, they'll go click, 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 deploy a virtual machine. And the most amazing thing that I see developers do is they'll have their continuous integration, which is hopefully, most of you know about continuous integration. It's where you write code and then it gets deployed automatically somewhere so that it gets tested, and then a green light goes off, and then you can then promote it to another environment. Now, what I've seen a lot of developers do in enterprises, they'll actually literally go into the AWS console and provision lots of servers, and then they'll take their continuous integration pipelines that they've got internally within their infrastructure, and they'll just plug it in to all this infrastructure that they've now just deployed into the cloud. And so what they're doing is they're just basically moving the servers that they were running their code on into AWS, but they haven't got any of the benefits of this kind of automation that I was talking about here. And I see that a lot. So there's a huge level of maturity that needs to take place in terms of enterprises with that. DevOps is around that kind of developers also deploying infrastructure as well, and operating the whole thing. Okay, I won't go into too much detail around that. Massive scale with cloud, as I said, with API Gate, with Lambda. I'll show you the little demo that I've got. Basically, the demo that I've actually going to show you in a sec, I almost don't have to worry about how big the thing gets, right? I've written it just for a little prototype, but there's no constraint really in terms of how often this API gets hit. It will just scale automatically. You know, I don't have to think about it, right? So there's the scale side of the cloud. Innovation. AWS just keep on innovating, and I am an AWS consultant, so obviously I'm going to promote their services. But the thing that amazes me is there was something called Athena that came out recently that AWS just released. AWS develop their services they're very isolated, and you'll actually see this when you go in the AWS console. You go into some services and the look and feel of the console is different to some other services. And the reason why is because they have teams that all work and just at just incredible pace in just improving their services, and they all change at different rates, right? And there was this one team who developed a new service called Athena, where basically you can run a SQL query against S3. You can have a terabyte or terabytes, 100 terabytes of data in S3 that you've just been storing there over the years. And with Athena, you can basically run a SQL query. If you're familiar with SQL queries, select this, where that, group by this, and spit out some result. And you can point it at a data store, at a bucket, which just has flat files on it. And what AWS behind the scenes do is they spin up millions or thousands or whatever of processes that will go and pick little bits of data and process them in parallel and then return the result back to you. Right, so this is what I mean about innovation. AWS build these services like serverless, and then other teams then build services on top of those, because it's just incredible scale. And so the innovation that's coming out of AWS is just phenomenal. And who knows where they're going to go next. There's a massive community around AWS. I feel like a bit of a fraud sometimes when I'm working with customers because seriously, there is so much knowledge online. You should never build something yourself without going and seeking to see if it's done elsewhere or something like it, because a lot of it has, right? I can't remember the last time that I've actually written something from scratch. Usually I'm taking something somebody else has done and I'm changing it. There's an incredible community around this, okay? OpEx versus CapEx, if you're not familiar with the finances of the cloud, enterprises love it, okay? Instead of paying for infrastructure refreshes, so usually with infrastructure refreshes, you'll have kit that you buy, say you buy $10 million worth of hardware and you depreciate it over 3 years. Okay, and then when it gets to the end of that 3 years, you've got to do a refresh, okay, because of certain tax implications with enterprises. The thing is with the cloud, you pay as you go. You don't have to pay for that 3 years, you just pay as you go. That's kind of a bit not exactly true, because with AWS you can actually save up to 75% of your bill by paying upfront for 3 years. So I guess you've got to decide whether you want the flexibility of optimizing your costs or whether you just buy for 3 years. Typically what big enterprises do is they'll actually work out a base load. Usually you can see through the tools that AWS provide, you can see your costs going up and down as you're shutting stuff down and deploying things and pulling stuff down. You actually see that there's a base level of load, and then you buy that if you're a big company. Self-service, obviously, but self-service can actually be bad. It can actually create bad habits. It's like I was saying about devs going, oh, server, deploy my code onto that through my continuous integration. Much better off actually trying to do your full stack deployment if you've got I know sometimes it's a luxury because it does take more time to develop full stack deployment. But ultimately then it means that you can basically tear down everything and then run a script to just build it again. Great for things like disaster recovery, business continuity. If you're a business that needs to replicate what you've done and perhaps put it in another region, all that automation's brilliant. Through APIs, that's what drives it all. It's APIs, it's programmatic access to deploying infrastructure. So security, I gave a tech talk at the first serverless meetup in Sydney about security in the cloud, and that was about the way that enterprises see themselves. They think that this firewall around their whole business protects them, and yet a lot of problems that happen with security issues in enterprise actually happening from inside. So the great thing about the cloud is security is a first-class citizen. Everything is designed with security. If you want to put security, say encryption at rest, right, for S3, which is their storage platform, and an EBS, which is their storage platform that connects to instances and stuff. Won't go into too much detail, but basically it's free, right? You just check a tick box and you've got encryption at rest. And if anybody gets hold of that physical hardware, they cannot access the files that are on there unless they've got the keys. Not all of it's free, by the way. I'm sort of making this sound pretty good, but there are some gotchas. I can tell you about them afterwards if you're interested. Ecosystem. So when I say ecosystem different from community, is around the partner network. So AWS have this massive partner network. Well, I'm a partner. So the company I work for is an advanced consulting partner. So there's all these partners that specialize in different things. The company I work for specializes in DevOps, which is about going into enterprises and showing them how to use the cloud in the most effective way for their business, rather than just going into the console and deploying servers. That's what our company specializes in. And there's other companies, other partners that specializes in, say, IoT, or in, data science, or that kind of thing. So there's this ecosystem of partners, and the other thing too is the Amazon Marketplace too. So you can go to the Amazon Marketplace and say you want a Drupal stack for some static website. You can actually go to the AWS Marketplace and you can look up Drupal, and it'll actually have Drupal stack, and you just click on it and it deploys a Drupal stack for you. So some company, what they've done is they've packaged up a managed service around Drupal. So there's this whole ecosystem around AWS services. And cost optimization. So AWS actually tell you how to save money. So there's something called Trusted Advisor in AWS. So if you're a big company that's got lots of infrastructure and you're worried about the costs going up, which happens to most companies, you go into Trusted Advisor and it will tell you that you can do these things to save money. Or I can say that these instances that you're running are running at 5% utilization, and you could save this much money if you change them to a different size. So there's all those aspects to it. Are there any questions about that? No, I'm babbling on, but I'll get to the good stuff in a sec. Okay, I said free. I don't know if anybody noticed free on that slide. It said free. So free really, kinda. Free really, kinda. Got the inflection wrong there. I thought I'd just show you this is I find this staggering, right? If you are a small business, or even if you're an enterprise and you just want to try something, right? The cost barrier to innovate and to try new things is so low. It's incredible. So you can see here on S3, which is like static web hosting, right? You can see how much that is. It's 2.5 cents per gigabyte for the first 50 terabytes per month. It's basically nothing. Okay. AWS Lambda, first 1 million requests per month are free. Okay. There is more detail about this on their website. Okay. I am just choosing some of the choice bits just to kind of get you salivating. But the thing is you can see, it sort of draws a bit of a picture, right? This is really, really cheap. You can try new things without really spending much money, apart from the cost of people to actually develop the product. The IT stuff is it just doesn't cost anything. So Amazon API Gateway. So you were saying how you use API Gateway in front of Lambda to kind of trigger that code, right? So you got $3.50 per million API calls received. DynamoDB. So I'm using DynamoDB to store the data that I get from my GPS tracker thing that I'm going to show you in a sec. First 25 gigabytes stored per month is free. Okay, it just doesn't cost me anything. I'm just tracking my car going around the street. And DNS, so 50 cents per hosted zone. So I've got a website, 50 cents for that zone per month, and it cost me $12 to buy the domain. Any certificates, so you know how you got like SSL, which protects us all from, people snooping and all the rest of it, completely free. AWS just throw it in. And they love doing that. And a lot of announcements you'll see if you watch their announcements for their products, they'll go blah, 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 and at the bottom they go, and it's free. Right? They're really good at doing that. So you can see it's not free, but seriously, it's basically free. Some of that. Sorry, yeah, go for it.
So I'm just starting a side project at the moment. It's going to involve storing lots of JSON documents. Aside from Redis, I've mostly worked with relational databases in the past.
Yeah.
And I'd like to avoid trying to ramp up my cost too much on Postgres and AWS.
Yeah.
Is it worth my while going to something like MongoDB?
Well, MongoDB, they don't, AWS, you'd have to deploy MongoDB onto AWS. DynamoDB is a JSON store.
Yep.
Elasticsearch is a JSON store.
Storing it as using the JSON on the pipe, which is available on Postgres.
Yep. We can have a talk about it afterwards. Yeah. The customer that I'm currently working for with the tracking the pets thing, they actually started with MongoDB and they reached a point where they can't scale anymore. And so now they're putting all of their data onto S3. So it depends on what you want to do with the data. Okay, so this is my little prototype. So I've been monitoring LoRaWAN for a while, right? Because I've just seen this technology. I saw this kind of like bit of a hole with long-range, low-powered, small data rate type technology. And there's been a bit of a hole, and I've kind of been looking at it over time. And then I saw Sigfox, which is another competitor to LoRa that came up, and LoRaWAN. I've kind of been looking at them, and I've got I don't know if you know that on Slack you can actually set up connection to subscribe to an RSS feed on Slack, and on Google, with Google Alerts. I don't know if you've ever used Google Alerts, but Google Alerts allows you to basically create a query, which will then basically search Google periodically, and then create a feed of all new things on the internet that match that criteria. So basically, I just typed in LoRaWAN into a Google alert, created an RSS feed, and then got Slack, which is like a instant messenger thing, to connect to that. And I just get pinged every time something from LoRaWAN comes up. And I've just been monitoring it over time. And that's the reason why I sort of said I can see this wave, because just over the last 6 months, it's just like this tsunami of people deploying this stuff. And I wondered if there was any LoRa technology down here, and I found out there was a LoRaWAN gateway at the uni here. It's been put in. I thought, oh, check this stuff out. So I sort of do a bit of hobby electronic stuff in my own spare time, because I'm just a bit of a nerd. And so I looked up how I could do this, problem solve. And so this chip here, I didn't bring it in. Sorry, I know you're probably all disappointed, but I didn't bring this in to show you. But there's this tiny little, it's about 1.5 times the size of a 20-cent piece, right? And in this chip is a LoRaWAN radio, or a LoRa radio, and an Arduino microcontroller. Could you just put your hand up if you've heard of Arduino, please? Fantastic. Excellent. So this is a great little piece of kit, because I just thought, this is great. This solves my problem. I don't have to start soldering things together or anything, right? So I got a radio and I got a controller. I can now, with the Arduino, I can take an input from my environment, whether it's temperature or sensors or GPS or whatever I want, and I can just send the data off into the void, and hopefully it'll be picked up by the LoRaWAN gateway here. And it's pretty embarrassing, actually. I was trying to work out how to use this thing, and so I was driving around Wollongong trying to work out how far away can I be without dropping out, and I was at a pet store over at Woonona or something for about half an hour, sitting in my car trying to get it to work, and couldn't get it to work, and people in the pet store probably thought I was mad. I had my laptop open and this thing up on the dashboard and messing around. Anyway, I couldn't get it to work in Thirroul. I had to keep on driving back down here to get it to work. So what I did was I took this chip that was here and stuck an antenna on it and plugged it, basically to cut a long story short. Oh, well, it's here anyway. I plugged it into a Raspberry Pi, and then I programmed the Raspberry Pi to send data to DynamoDB, which is an Amazon web service. Now, the data that it was sending was coming from another LoRaWAN chip that had an Arduino on it, but it's connected to a GPS tracker. Now, you might think, everyone's got GPS. It's in my phone, like it's all over the place, right? And, this is spoiling my fun here, though, because I'm just trying this stuff out and learning. So what I wanted to find out is, could I create a GPS tracker that didn't use 3G and didn't use Wi-Fi? I thought, is there a problem to be solved there? And so I stuck 3G on this chip, and every 3 seconds sent the location to this guy here and sent it to Amazon. And then for the next 3 weeks, well, not the next 3 weeks, I actually plugged that thing into the USB port of my car, and my wife thought I was tracking her or something and didn't want me to have it plugged in while she was in there. But no, it wasn't that. I just wanted to see how far it would go when she was driving around the streets. And so I drove all the way around Wollongong, up to the escarpment, up to Bulli, the lookout up there and all that kind of thing, and try to see how far this thing would go. I'll show you the results in a sec. The other thing I did is I needed to be able to visualize my data. So on S3, have I got S3 here? Yes, I have. On S3, you can basically just put like a HTML page, just a static web page, and you can access that, which I'll show you in a sec. And in that S3 web page was some JavaScript, and every few seconds it would just basically hit this API gateway and say, give me the latest data. And then that API gateway would hit the Lambda function, and the Lambda function would actually go and grab the data from this DynamoDB database here, and then it would return it. And it doesn't cost me a cent. Actually, it does. It's about 3 cents or something. I've got some other things over here, this certificate manager here. So I've actually put a domain name on this bucket. So when you hit it, it's actually got a proper name. Something.com. I won't tell you what it is. And it's free. The certificates are free. And IAM is it's basically a identity and access management service. So I can actually secure this. So when I'm putting data in here, I have to use credentials to actually access it, to put the data in. I don't care if people can see the data, it's just putting in. I need some security for this. And so I set up this little prototype. And this is what I came up with. So, so my house is there. Thirroul train station's about 800 metres away. And so you can see the top of the escarpment is probably about 2 kilometres or so. So I guess this is the insight into, is this LoRaWAN technology actually useful or not? In a residential area, we've got lots of houses and buildings. You're going about probably 400 metres, okay? But if you've got a line of sight, because you can actually see my house from up the top there, then you can go 2 Ks. And I actually don't know how far that goes. So the technology is supposed to be able to go about 10 Ks. And so just with this little prototype, which has basically cost me nothing with AWS services, and to be honest, it's probably cost about $200 in electronics with GPS trackers and chips and all the bits and pieces that go along with it, Raspberry Pi. So I've come up with this prototype. And so I guess it's been very long-winded, but I hope you've learnt something from it. The bottom line is that if you have an idea, that there is a very low barrier to access technology to be able to bring that to fruition if you have the skills, or if you have access to skills, because the technology is very cheap. And the community that's around all this technology, even with the radios, I got them from a website called Adafruit, which is a American company, and I basically just ripped off their code, modified it to stick a GPS in it, and it worked. So the community that's around all of this as well enables us to build new products on the top. It's like standing on the shoulders of giants type of thing, except I'm not sure if the lady who runs Adafruit's a giant or not, but she's pretty cool. But that's basically it. So that's all I've got to say. Are there any questions? Yes?
The serverless stuff, you mentioned AWS Lambda, but also Azure has the equivalent and a few others. Is that region specific, or is that when you set it up, it's just with the
it is
gateway?
Well, AWS is region specific. I'm not sure about, just to be completely honest with you, I don't know a lot about Azure or Google Cloud Functions. Something that is very interesting about the development of technology, that's a good question you just asked, because Google just recently came out with a database technology. I can't remember what it's called off the top of my head, but they just recently came up with a database technology, a relational database technology that is a geo database, right? So it's not regional. So basically, it's this whole concept of, you know, if you write data here, it's available everywhere else in the world. You don't.
Eventual consistency, or
they have some sort of technology that handles all of that. I don't know the full details, but I don't know, somebody else here might. But things are sort of going that way of moving away from this regional kind of concept to just this hugely distributed system, right? So, I mean, even with Bitcoin, you think about Bitcoin, and there's a technology called Ethereum, and they talk about this thing called a singleton, right? And it sounds like science fiction when you listen to this stuff. Is this idea of you have this ledger that is global and is transactional, and they talk about writing code on this thing, and it's like this weird science fiction type concept of a single computer that covers the whole world kind of thing. It's like this weird. You can look it up. Ethereum. Type in Ethereum singletons, and there's videos on this stuff, and it just really sounds really weird. But it's the way technology is going. Is instead of thinking of regions, thinking of just a global endpoint where you just access services, and of course there are issues around synchronization of data and all that kind of stuff, but there's a lot of data science behind, or a lot, sorry, computer science around how to get that consistency. Yeah. There you go. Anything else?
Thanks, Marty. That was awesome. Thanks so much. And Marty's around to answer questions. He's got cards here if you need them and want to have a chat later.
Take a business card if you're interested in AWS consulting.
If you're interested. So we're going to break now. Feel free to grab another beer, hang around and have a chat. Any questions for Marty or anyone else that has questions about stuff, make sure you meet everyone. And please let me know if you've got a talk that you'd like to give at the next Silicon Valley Tech Talks, or if you have something you'd like to learn more about, a particular topic you'd like to learn more about, and we can try and find a speaker to come in and share some of their experience and knowledge with us. So yeah, thanks so much for coming out this evening, and thanks Marty.
Thanks.